Hi, this is Adrian from Live to Learn Academy, and today we'll be going over lesson 2.4 in the Nelson Advanced Functions textbook labeled Using Rates of Change to Create Graphical Models. So, if you're somebody who's looking for tutoring and this is a course that you're struggling with, feel free to click the link in our description. It'll take you to our website, fill out the form, and our team would love to get in touch with you to help you throughout your semester. But without further ado, let's get straight into it. So, using rate of change to create graphical models. There are some key concepts in this lesson that we want to go over, and some of these tie into physics. And if any of you guys have taken grade 11 physics, this may be a unit that is very transferable in terms of skill set. So a couple things we need to know is we need to understand displacement time graphs, okay? Displacement time graphs. So there's a couple graphs that we need to know, and we need to actually see what these graphs actually mean in reality. So if you have this, I'm going to just make 3 of them. Okay. So mind you, this is displacement, this is time, displacement, time, displacement, time. Okay, so there are 3 different types of graphs that you have to become aware of. One looks like this, one looks like this, and the other looks like a flat line. So what we need to do is we need to be able to look at these graphical models and really understand what's going on when it comes to these word problems. So what this graph says is that displacement increases as time increases, which is pretty straightforward, right? This just means that the slope is positive. That's what we have over here regarding this graph. Now, from that, another thing we should know is for the second graph is very similar. Whoops. The second graph is very similar. But in this case, displacement is decreasing, not increasing. Therefore, the slope is negative. Okay, so one is displacement is increasing, it's a positive slope. The other is displacement is decreasing. The third one is there's no change in displacement. So as time increases, no displacement as time increases. And this is known as a flat line, where the slope obviously would be m equals 0. So anytime you see a flat line, right, you have to understand that no displacement is actually occurring during this time. Now, this seems pretty straightforward with straight lines. But what happens when we have curved lines? So let's take a look at another example. What if we had curved lines? So what if the displacement looked like this or like this? So if you look at this, we know that these functions are increasing functions because if we take a slope at any of these points, these are positive slopes. Therefore, we know these are increasing functions. So both of these are increasing functions. But there's something that we need to understand. The function is increasing, but what is happening to the speed in these functions? So one thing that I have to let you guys know is that if I have a displacement time graph and I take the slope of the displacement time graph, I'm going to get the velocity time graph. So this represents your distance, but velocity represents your speed, if you remember from grade 11 physics. So something we need to know with this concept is that even though these are increasing functions, there's something happening to the speed as we go up these slopes. So if you look here, if I take this slope, and then I take this slope, and then I take this slope, For example, let's say the slope of this is 1, the slope of this would be 2, and the slope of this would be 3. As you can tell, as I go from left to right, so as time increases, my speed is actually increasing as I go. So speed increases as time increases. But if I look at this function on the other hand, from left to right, this function, the slope may be 3 here, 2 here, and 1 here. So in this case, speed decreases as time increases. So there's a big difference here, right? Even though both of them are increasing functions, right? They're both an increasing curve because if we take any of the slopes, they're all positive. So this has to do with the slopes being positive, right? That's what determines if it's an increasing function or if it's a decreasing function. But if I'm talking directly about the speed as a speed in reference to the time, the speed is increasing as time increases in this function, and the speed is decreasing as time increases in this function. So there's a clear difference, okay? So I don't want, a lot of people confuse this. They say, oh, it should be increasing because the slope's positive. Yes, the function is an increasing function. But when we're talking about speed specifically, we're looking about how that slope transitions as it goes from left to right within the graph. Okay, with that being said, we're going to go into another example. Actually, I'll put it down here. Go through another example over here. What if I had a graph? So let's say we had this and we had this. Okay. Remember, these are still displacement time graphs. What if the curve looked like this or the curve looked like this? So look carefully. In this case, we know all of the slopes that are on this line are going to be negative slopes. Negative slopes. So if all of them are negative slopes, then these are decreasing functions. Mind you, both of these are going to be decreasing functions because we have negative slopes. So that has to do with the slope. Is it positive or is it negative? Now, what about the speed? Well, if I take a slope here, a slope here, and a slope here, right? This may be a slope of -3. This may be a slope of -2. This may be a slope of -1. So in this case, my speed decreases as time increases. So the slope is getting smaller and smaller as I'm going from left to right. Or what about this guy? My slope starts like this. Maybe it's at -1, and then it goes to -2, and then it goes to -3. As you can see, the slope keeps getting steeper, steeper and steeper and steeper. Therefore, for this guy, my speed would increase as time increases. But notice, even though one's increasing as time increases and one decreases as time increases, the actual function themselves are decreasing functions because of the slope. So this is something that we have to really understand carefully as we go into problems. Because some questions will ask you, what type of function is it? Is it an increasing function or is it a decreasing function? That's a different question because that's just talking about, is the slope of the tangent positive or the slope of the tangent negative? But if they're asking you what is happening to the speed in relation to the time, then we actually have to look at how these slopes are progressing as we go from left to right within our graph. How are they progressing? Are they getting more steeper from left to right, or are they getting less steeper from left to right? If they're getting more steeper, then you know the speed is increasing as time increases from left to right. If they're getting less steeper, right? So I can write that over here. If the slopes become more steep from left to right, then you know speed. So this is here, I'll just write it here. Speed increases if the slopes become more steep from left to right. And then in the same respect as this, I will also write here speed decreases as the slopes become less steep from left to right. So notice the key words. When speed is increasing, you become more steep. When speed is decreasing, you become less steep. It looks like it says move, but it says more. Okay, so hope this lesson kind of gave you guys some good perspective on displacement time graphs, how to kind of read these things going forward. You probably will get tested on this. It probably will be one question on your test about this. So I would just take a look at this lesson, rewatch it, send it to a friend if they need help with this lesson. If you're somebody who needs tutoring, feel free to click the link in our description. Our team does tutor advanced functions regularly throughout the school year. So if you are somebody who's interested in that course, feel free to fill out a form, and our team would love to get in touch with you. But without further ado, I'll see you guys in the next video.